Hi, welcome to today's lesson. What we're going to be looking at today is simultaneous equations, specifically simultaneous equations with one linear and one quadratic. Okay, it will really help if you've looked at simultaneous equations with two linears before. Okay, right, so simultaneous equations, linear and quad. You can get a simultaneous equation with two quadratics, but that becomes really tricky. That's like year 11, high year 11, year 12 stuff. Okay, right now let's just keep it simple, linear and quadratic. Okay, there's two ways that I'm going to show you. The first way, number one, is equating. Now it's outlined on the notes about what this means. Oh, good catch. With equating, what we're going to do is we're going to get y alone, okay, make y the subject of the formula, okay, you've heard that phrase before in some of my other videos, okay, so get y alone, and then equate the two x parts to each other, okay, then we're going to solve that quadratic back substitute for y, alright. The second option we'll get to in the next page. So, let's get cracking on this one. Let's use these two, e.g., y minus x equals 1, y minus x equals 1. I'm going to call this equation number 1, okay. This is my equation 1, alright? And then the other one is y equals x squared minus 1, and this guy I'm going to call equation number 2. Are you with me? Okay. So, I take a look at what I've got here, and I say, okay, I've got a linear, the highest power is 1, and I've got a quadratic, the highest power is 2. Okay, so what I'm going to do is I'm going to get this y alone. Okay. So I'm going to move everything away, and I'm going to do it here. I'm going to use OTOS, opposite to other side, to change y alone, make y the subject of the formula. Very straightforward. The opposite of minus x, plus x. So I've got y equals plus x plus 1. 1 plus x plus 1, same thing. Okay, I just like writing my variables in front. That's the only reason why I did it like that. Okay, so now instead of using this one and this one, I'm going to use this one and this one. This is the same. These two are exactly the same. So I'm going to use the red one and this one. And what I'm going to do is I'm going to equate that, the x parts, x plus 1, alright, equals this one, x squared minus 1. X squared minus 1. Alright, so you equate the x parts. And then you stop. You take a breather, have a cup of tea, and you come back and you go, okay, wait a second. This is a quadratic. What are my rules for solving a quadratic? My first rule is I've got to get everything onto the quadratic side. Okay? Everything onto the quadratic side, then factorize. It doesn't really matter if you get everything onto this side, or you get everything onto that side. I personally like to live with a positive a, meaning this has to be positive. So if I have to pull him onto this side, it will become minus x squared. So instead of moving him here, I'm going to move everything there. 6 or 1 half a dozen the other. So I've got 0, nothing is left here, equals, well, I've got the x squared, right? X squared minus 1. You're with me? Okay? And I'll move this over. The opposite of plus x is minus x. The opposite of plus 1 is minus 1. Everyone with me? So I've just moved everything to that side. And now we tidy it up. 0 equals x squared minus x minus 1, and minus 1 is minus 2. Are you with me? Fantastic. Quadratic. Everything's onto that side, so it's in standard form. So all I have to do now is factorize. Okay? So it would help if you'd watched how to solve quadratic equations before you come to this one. Alright, so 0 equals factors of 2, okay, they give me 1. Well, the only factors of 2 are 2 and 1. Okay? This sign says the signs have to be different. This sign says the biggest one is negative. Minus 2 plus 1. Are you with me? Like I said, if you've watched solving quadratics before, this will make a little bit more sense to you. Okay, so that gives me two options. Either I have got, from here, I've got x equals 2. I'm just jumping a step there. Or from here, I've got x equals negative 1. Okay, quadratic, two solutions. Alright, it's what I expect. This is where the theory comes in. You know your theory, you know the quadratics should give you two solutions, so start to expect this in your working. So if you make a small mistake, either understand why you've only got one solution, or go back and check your working. Alright. Okay, so there's my two x's. All I have to do is get a y. So the easiest thing, I think, is to take your two x's and don't substitute them into your quadratic. That's an extra step. Substitute them into your linear. In fact, don't substitute them into this one. Put it in that one. There's one. I just plug it in there and I get y. So if I plug it in there, I'm going to do the working underneath here, right? If I plug 2 in there, so I've got y equals, I'm going to use x as 2, you with me? Plus 1. So my answer for this one, y equals 3. That's my first option. The next one, y equals x is negative 1, right? Negative 1 plus 1. So y equals negative 1 plus 1 is 0. Everyone with me? Okay. So there's my two options. I either have, when x is 2, y equals 3, or when x is negative 1, y, oops, wrong color. I love color coding. Y equals 0. Alrighty. So there's my two options. Now, whether you write them like that, or whether you're required to give them as a coordinate, it's all up to the preference of the person who's writing the test, your teacher, your exam board, whatever. So you must just check with your teachers whether it's two solutions like this, or whether they require you to give it as a coordinate. Now the interesting thing is, think about the graphic of this. Think about how this thing looks. If I had to plot these two very roughly, this is not accurate, please note. If I had to plot these two, I've got a quadratic, right, which is symmetrical about the y-axis, crosses at negative 1, and I've got a linear, okay, with a positive gradient that does this, okay, and it does this. Oops, crosses there. So there's my 2 points of intersection. There's that one, and that one is that one. Right, but you don't need to do that using a picture, because you have to do it algebraically. You have to know how to do it algebraically. Right, so this is the one option of doing it, equating the x sides, getting y alone, equating the x sides. This is nice. I'm not a big fan of this one, even though it's quite straightforward. I'm going to show you the one that I actually am more of a fan of, because this works with a number of different options. Okay, this works when you're equating a circle equation to a linear, for example. I would use this one as well, but that's a little bit more advanced. So this number 2 is called substituting. Substituting. Okay, so what does this say? This says I still get my y in terms of my x, so I still make my y the subject of the formula, but instead of equating the x sides, I then take that x and I replace it for the y in the other one. Are you with me? Okay, so I am going to do a linear with a circle in here. So let's take a look at this one, e.g. Okay, so I've got a linear, y equals x minus 5, okay? Getting y alone shouldn't be that much of a hassle for you if you're at this stage. If you're already looking at solving simultaneous equations that are quadratic, changing the subject of the formula for this one is really straightforward. Okay, and then I've got this x squared plus y squared equals 17. Okay, so this is equation number 1, right? And this I'm going to call equation number 2. Right? You'll often see this way of labeling things done. Now, alarm bell should be ringing, because if I've got an y squared, it's going to be really difficult for me to get x completely alone and then equate the two parts, because this is not y, it's y. This is not y, it's y squared. This is y, so I have to square that part. It's a little bit tricky. So the easiest thing for me to do is just to take this and replace it into here. So I'm going to rewrite that quadratic here. I'm going to rewrite equation 2, are you with me, as x squared plus, now I'm going to put what y is. Y is this, x minus 5. That's y, there, right? Squared equals 17. So I've just rewritten this, but put y as x minus 5, okay? Now, you should have also looked at how to multiply out brackets. When I multiply out a bracket, it's not x squared minus 5 squared. No, please don't make that mistake. It's bracket times bracket. So you either use FOIL or you do that trick that I do in my shortcut. I'm going to use a trick. Okay, so I've got x squared plus the trick that I did on my shortcut of how to square brackets. Square of the first, x squared, first times the last doubled, minus 10x, square of the last plus 25. Alright, so that's the bracket multiplied out. Okay, so if you want to do FOIL and multiply out the bracket, no worries, but you must do this to multiply out properly. Okay, binomial, squared, trinomial. Okay, bracket times bracket, trinomial, 1, 2, 3. It's what you expect. Again, this is where the theory is coming in. What do I expect? Does my working correlate with my theory? Okay, so we just tidy this guy up now, right? X squared plus x squared is 2x squared minus 10x plus 25 minus 17. Now I did that to make it equal 0. I brought the 17 across. Last thing, 2x squared minus 10x, 25 minus 17. 25 minus 17, oh, I've gone completely blank. 25 minus 17, 8 plus 8 equals 0. You all still with me? Oh, look, 2, 10, 8, all even. Let's take out a common factor. Divide everything by 2, okay? X squared minus 5x plus 4 equals 0. 0 divided by 2. I just divided the whole thing by 2 to get rid of that leading factor, okay? Fantastic. This is much easier to factorize than that, okay? That's the reason why I did it. So I've got x equals 0. It's long-winded, huh? But we're getting there. We're almost finished. Okay, so what I have, I've got factors of 4 that give me 5, or factors of 4 and 2 and 2. So with 2 and 2, I either get 4 or get 0, or 1 and 4, which means I either get 5 or I get 3. So 1 and 4 is the one I want. 4 and 1. This sign tells me the signs are the same because it's plus. This sign says the biggest one's negative. Well, if the signs are the same, negative, negative. You all still with me? Okay. So that gives me two solutions. I've either got x equals 4, or I've got x equals 1. X equals 1. Okay? And now, just like I did with the last one, I'm going to back substitute it into equation number 1. So I've got y equals, alright, 4 minus 5. Substitute into linear. Don't waste your time substituting into quadratic. Why give yourself extra work? Okay. So y equals 4 minus 5, so y equals negative 1. Or I've got y equals 1 minus 5. 1 minus 5, minus 5, which gives me y equals negative 4. Are you with me? And there we are. Done. So when x equals 4, y equals negative 1, y equals negative 1. Or when x equals 1, y equals negative 4. Okay? If you're looking at the picture for this, I know I'm going a little bit long here, but if you're looking at the picture for this, I've got something along these lines. So there's my circle, which I've done as blue. So my circle looks like that. Okay, center on the origin. We'll talk about why the center is on the origin in another video. Okay? And my linear equation is a positive gradient going through negative 5. So it's a positive gradient going through negative 5, and it looks something like that. So there are my 2 points. Okay. I always think that it's a great idea to know what the two things look like, and then quickly draw a sketch of what you think it looks like to double check whether your coordinates make sense. 4, negative 1, alright? 4, negative 1, this thing is a little bit, I've drawn this slightly wrong, and 1, negative 4, that's about right. Okay, alrighty, so there's more on the blog, there's more on this channel. You know what to do, I've said this 1,000 times already. Okay, remember I'm here for you.